In example 4, A and B are a review of already things that we did in example 1 and 2. And C is the first time where we get to see what does a vertical translation do to a sine and cosine graph. So starting with A, and again, these ones say graph between 0 and 2 pi. I'll graph at least one period, so I'll put the arrowheads on to end, but you could just go from 0 to 2 pi. So y equals 3 sine x, that's a value in front. That 3 out in front, that's your A value. That's going to affect your amplitude because it's a vertical stretch. So what does that look like? Well, when we go to graph it, instead of marking our maximum at 1 and our minimum at -1, we mark our maximum at 3 and our minimum at -3. Our center line is still at 0. And now we're going to go to a maximum of 3 and a minimum of -3. Remember that your amplitude is that measurement from the center line to your maximum or from your center line to your minimum. And so our period is 2 pi still. We still split this into 4 equal sections. Half of 2 pi is pi, half of pi is pi over 2, and 3 pi over 2. And from this, sine graph starts in the middle going up. So then we go to our maximum value, back to our center line, back to our minimum value, and back to our center line. And again, I said I'll draw arrows to continue. This question actually wanted you to start at 0 and stop at 2 pi, but this would continue on forever. In part B, we have sine of 3x. This 3 would be a horizontal compression. You would multiply your x values by 1/3. Now we have a formula that we created that says your period in a sine and a cosine graph is always equal to 2 pi over your b value. And since our b value is 3, we would get 2 pi over 3. We could probably also see this just by thinking about horizontal compressions. Our period was 2 pi. You compressed it by a factor of 1/3. That would mean multiplying all your x values by 1/3, and so your period of 2 pi will now get squished to be 2 pi over 3. So what does that look like on our graph? Again, we start by using our amplitude to mark our max and our minimum. And so our maximum here will be 1 and our minimum -1 because our amplitude is 1. What's different is now we mark our period here. Instead of marking it as 2 pi, we mark it as 2 pi over 3. But we still, just like before, divide it into 4 equal sections. Our graph is going to look really similar to the one above it because my scale is different. But it doesn't matter what scale you use as long as you're marking your period and labeling it. And then we need to label each of these 4 sections. What's half of 2 pi over 3? That would be pi over 3. What's half of pi over 3? That would be pi over 6. And when marking the third one, I use the one that I have to begin with. This is pi over 6. That means each of these marks, since they're equally, would be 1 pi over 6. 2 pi over 6. This would be 3 pi over 6. You could reduce that to pi over 2 if you wanted to, or you could leave it as 3 pi over 6. So where does our sine graph start? In the middle going up. So then it'll go middle to maximum to middle to minimum to middle. And there's our graph. Again, I put the arrowheads on it to say that it continues, because this one would be a little bit tricky to graph between 0 and 2 pi, because you would have to keep going and have 3 full periods to show it. So again, usually what they say on the final exam is to graph at least 1 period. And finally, in part C, We have a +3 after. That is going to be a vertical translation 3 units up. And something that we haven't labeled so far that we're going to label in this one is that d value, the last translation up or down, always affects your center line. The center line of a sine and cosine graph starts at 0, and so you almost never graph it or show it on those regular graphs. But once we move it up 3, we're going to show that with a dotted line, preferably in red if you have red. Label it at y equals 3. Like an asymptote, again, a dotted line on a graph is there to help you graph, but not part of the graph. So that's why we draw it as a dotted line, because it helps you graph something, but not part of a graph. An asymptote helps you draw the graph, not crossing that, but it isn't actually part of the points of that graph. So what happens with that d value, sine x plus 3, that plus 3 moves everything up 3. Our amplitude is still 1, but now our amplitude is from your center line to your maximum, so our amplitude tells us now our maximum is 4 and our minimum is 2. We still mark our period. In this case, our period is 2 pi and divided into 4 equal sections. And a sine graph starts in the middle going up, or starts on your center line going up. So now our graph starts there. At pi over 2, it'll be at our maximum. At pi, it'll be back to the center line. At 3 pi over 2, it'll be at your minimum. And at 2 pi, back to your center line. So again, I'll put the arrowheads to say that it continues and graph at least one period here. So now we've seen each of the translations separately. What we're going to do in section 6.6 is put them all together. And we're going to use some of the patterns that we've noticed while working with them separately to help us graph it in a quicker way than going from left to right with all our transformations. We could use our old techniques of going from left to right with our transformations, but noticing certain patterns that happen. Noticing that your center line is affected only by the translation up or down at the end. That your amplitude, whatever number is your vertical stretch or vertical compression, makes your amplitude. You'll be able to use your center line to find a maximum using your amplitude and a minimum using your amplitude. We know how the b value affects our period, and we'll be able to graph that. So we'll be able to put all of them together. Right now, I'd like you to try some more of these. So questions 6 and 7.